Hello and welcome to our video on full adder or full bit adder. Now if you watched our half bit adder, you remembered that there's no carry in bit for half bit adder. And what makes a full bit adder different is that there is a carry in bit. This means that you're able to do addition with multiple digit binary numbers by using a full adder for each digit. So before we get to our truth table in the circuit, let's take a look at this example. So here we have two 4-digit binary numbers. We'll label them A and B. And if you notice, A equals 6 and B equals 7. So we're just going to do some simple binary addition. I'll walk through it. 0 plus 1 is 1 with a carry-in of 0. 1 plus 1 is 0. 1, which is the carry out, and then it becomes the carry in. 1 plus 1 is 0, plus 1 is 1. The carry out of 1, and 0 plus 0 is 0, plus 1 is 1. Now, if you want to check your work, you can go ahead and do that on the side. You can just transfer the binary numbers to decimal numbers, and you'll see that you get 13 here, and that is in the range of a 4-digit number, which is 0 to 15. So now that we know what this is, we can notice the terminology that I used when we were doing the addition. When we had 0 plus 1, we had our sum bit, which was 1, and we had a carry out bit of 0. Then, when we did the next digit, which was 1 plus 1, we had a carry in bit of 0. So that's what a full adder takes into account. So now that we know a little bit of what a carry in and carry out is, let's take a look at our truth table. Now our truth table is just a bunch of addition using A, B, and our carry in bit. So 0 plus 0 plus 0 is 0 with a carry out of 0. 0 plus 1, 1, carry out 0, 1, 0, sum is 0, our carry out is 1. 0 plus 0 is 0, plus 1 is 1 with a carry out of 0. 1 plus 1 is 0 with a carry out of 1. 1 plus 1 is 0 with a carry out of 1. And 1 plus 1 plus 1 is 1 with a carry out bit of 1. So now we have our truth table completed. You can see that it's a lot longer than a half bit adder because this time we have 3 inputs instead of 2. Let's do an example now with full adders and multiple digit binary numbers. Okay, so now we're going to take our full bit adder of A and B from the earlier example, and we're going to change it into our full bit adders. So when you have multiple digits, you're going to want to label them. So we'll make a little chart here. And so this first one, all of these, it will be A0, B0, S0, etc. This will be A1, B1, S1. This will be A2, B2, S2, and A3, B3, and S3. So now that we have our inputs and our output labeled, you can now transfer them to our full bit adders, and you can see that I've already labeled them. We've got B0, A0, B0, S0, A1, B1, S1, and so on. Now, you'll also notice that right now on our circuit or our just drawing, there's no carry in bits, and that's because you're about to draw them with me. So let's start with our first digit, A0, B0. We have 0 and 1. So I'm going to write 0 and 1 above our A and B. You cannot see that in the camera. I'll change to blue. I'm going to write 0 and 1 over A and B. Our carry in to start with initially here is also 0 because we haven't done any addition beforehand. And in this graph, we're going to be moving right to left, just following the 0, 1, 2, 3 progression. So we'll do our addition. 0 plus 1 with a carry in of 0. The sum equals 1. And our carry out bit is 0. So there's our carry out bit. And our carry out bit is 0. Now, you'll notice that from our earlier example, when we had our carry out bit become our carry in bit, it's the same thing here with the wires. So our carry out wire becomes our carry in wire, carry in 1, for the next full bit adder. You'll also notice, a quick side note, that each digit we have 4 digits, there's going to be 4 full adders. full bit adders. So that's important to remember. Let's continue. Our next one is A1 is 1, B1 is 1. And our carry in is 0. So 1 plus 1 is 0 with a carry out bit of 1. Carry out is 1, which means that this carry in is 1. Our next digits are 1, 1. So 1 plus 1 plus 1. Our sum is going to be 1, and our carry out is also going to be 1, which makes our carry in for the next one a 1. And A3 and B3 are 0 and 0 with a carry in of 1. That becomes a sum of 1 and a carry out of 0. I don't know if you can see all too well in the video, but we're now going to take all of our sums, and you'll notice that those 4 digits match our original sum that we got from our normal addition, which is 1101, 1101, with a carry out bit of 0. And the carry out bit is 0 and should be 0 because our answer is 13, which is within the range of a 4-bit binary number, which is 0 to 15. So if our answer was, say, 17, we'd have a carry out bit. So that is everything you need to know about a full bit adder. If you have any questions or comments, go ahead and let us know in the comments below. But yeah, that's all you need to know. Thanks for watching.